Right, we've been talking about similar polygons and proportions, and so now we're going to move to more specifically talk about triangles and the similarity between triangles. So just like we had some shortcuts dealing with congruent triangles, we have some shortcuts dealing with similar triangles. First of these is called the angle-angle similarity theorem, which says that if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. And this should kind of make sense because if I know what two angles of a triangle are, I can add them together, subtract from 180, and find out the third angle. So I don't really have to know the third angle as long as I know two of the angles. And so if I can match up two pairs of angles from two triangles, then I know the third angle is also going to be congruent, and so the triangles are going to be the same shape. So in this example, I have angle M is congruent to angle P, angle A is congruent to angle O, so therefore the triangles are similar by angle-angle similarity. And again, the little squiggle that you see either between the similarity statement or at the end of the angle-angle similarity statement means similar. Next we have side-side-side similarity, because we don't have enough S's there. And it says that if three sides of one triangle are proportional to three sides of corresponding sides of another triangle, then the triangles are similar. So in this case, if we know all the sides, we don't have to know anything about the angles. And so you would just compare the ratios of the three sides. So 18 over 24 is equal to, what is that, 12 over 16, which is equal to 30 over 40. And so you can cross multiply and check all those ratios, and it's going to come out to be the same. So therefore, you've got side-side-side similarity. The third method is called side-angle-side similarity, and it says that if two sides of one triangle are proportional to two sides of another triangle, and the included angles are congruent, then the triangles are similar. So this is a case here where I've got this side of this triangle is half of that side. This side here is half of this side, so I have the same ratio between the sides. And then the angle that's between them, so angle L and angle T, are congruent, and so that means that the two triangles are congruent by side-angle-side similarity. So for example, I want to explain why these triangles are similar and then write a similarity statement. Well, on first look, it's saying, well, they don't have the same angles. Well, let's take a look. We've got one angle missing on each triangle, so let's see what we can figure out here. Well, I know that the angles have to add up to 180, and so if I subtract off that 90-degree angle, so I'm left with 90 degrees to go. And so 90, so these two angles here, so 90 minus 56 gives me 34. So this angle here is 34, and that angle there is 34, which means that the measure of angle V is equal to the measure of angle X, and therefore angle V is congruent to angle X. So I've got my angle, and then I've got my two 90-degree angles, which are going to be congruent to each other. And so therefore this is going to be similar by angle-angle similarity. Okay, next example, we want to verify that triangle SAT is similar to triangle ORT. Well, first off, I know that angle ATS is congruent to angle RTO because those are vertical angles. Remember, anytime two lines cross, it forms vertical angles. Next thing I want to check here, now this is where probably the trickiest part of this comes, because you have to make sure you know which sides you're going to be comparing. Okay, so I'm going to compare, if you look at how this thing is oriented here, in order for these two angles to be corresponding, 12 and 16 are my corresponding sides. Okay, does that make sense? I have this obtuse angle here, which is across from the 15. I have an obtuse angle here, which is across from the 20. So the 12 and the 16 match up, and the 15 and the 20 match up. And then I want to have, I'm doing my left-hand triangle on top, my right-hand triangle on the bottom, and so that's how I set it up. So now I want to check to see, are these two pairs proportional? Do they have the same ratio? So I cross multiply, and I get 240 is equal to 240, so I know that they are proportional, and so therefore this would be similar because of side-angle-side similarity.